Hello and welcome to this on-demand recording for Empowering Year 2 Success for Digital Support Service T-level students with specific reference to preparing for the occupational specialisms. So the aims of this session are to guide and support your planning and delivery of Year 2 in the Digital Support Services T-level, specifically focusing around the occupational specialisms. So in Year 2, learners move away from broad core content and focus entirely on their chosen occupational specialism. In this route, learners will complete 3 assessment tasks, each mapped to the technical and professional skills required in real-life digital roles. Students will specialise in one of the following areas: digital support, digital infrastructure, network cabling and cybersecurity. And each pathway develops applied skills such as configuring and troubleshooting infrastructure, supporting end users, or installing network hardware, all aligned to current industry expectations. All content delivery, skill building and rehearsal should be completed before the controlled assessment window opens in March. So let's explore how we can structure the year to ensure students are ready technically, professionally and confidently for their final assessments. So what does change in Year 2? Well, in Year 2 of the Digital Support Services T-level, the emphasis shifts heavily towards occupational competency. So students move from understanding core principles to demonstrating role-specific skills in line with industry expectations. So students are expected to apply what they know in realistic scenarios using tools, systems and workflows that reflect the real-world roles that they're training for. So this could mean, for digital infrastructure students, configuring and maintaining IT infrastructure. For network cabling students, installing and testing physical cables and equipment. For digital support students, it could be supporting users and troubleshooting software or hardware issues. And for cybersecurity students, it could be maintaining cybersecurity protocols and recommending risk mitigation. Students will also need to follow standard operating procedures. They'll have to work independently within defined boundaries and be able to demonstrate safe, secure and compliant working practices. And this could include tasks like patching systems, validating installations and documenting work accurately. Students will also be required to apply digital security procedures. So learners must understand risks, follow organisational controls, be able to keep systems and data safe from threats, have an awareness of security and embed that into technical tasks. And they also, finally, must be able to evaluate and apply their knowledge. So across all of the pathways, students must show that they can locate and interpret technical documentation, use guidance or online sources, and make justified decisions based on evidence and best practice. The students must also develop workplace readiness, focusing on communication and effectively with colleagues and clients, meeting task requirements on time and to standards, and reflecting on and refining their practice, especially in evaluation tasks. So in summary, Year 2 is all about preparing students to be trusted technical professionals with an emphasis on competence, compliance and consistency. So not just knowing what to do, but how to do it accurately, securely and independently. And within this, you may find that your role shifts from teacher to coach, so modelling accuracy, supervising processes and encouraging improvement with your students. This slide gives us an overview of the performance outcomes for the T-level in digital support services. These outcomes are what students are ultimately being assessed against, and they help us keep our teaching focused on the knowledge and skills industry expects. So across all routes, whether students specialise in digital infrastructure, digital support, network cabling or cybersecurity, we can see that performance outcome 1 is consistent. It's about applying procedures and controls to maintain the digital security of an organisation and its data. Security underpins every specialism, so it's a common thread running through the qualification. From there, each pathway has its own focus for performance outcome 2. So for digital infrastructure, students need to be able to explain, install, configure, test and manage both physical and virtual infrastructure. For digital support, it's about installing, configuring and supporting software applications and operating systems. For network cabling, the emphasis is on installing and testing cabling in line with technical and security requirements. And for cybersecurity, it's more analytical. Students need to propose remediation advice following a risk assessment. Finally, performance outcome 3 is again consistent across all the pathways. Students must be able to discover, evaluate and apply reliable sources of knowledge. This highlights the importance of research skills and the ability to make informed decisions, which are essential in a fast-moving digital sector. So when you're planning schemes of work and sessions, it's useful to keep these performance objectives at the front of your minds. They provide a clear link between what happens in the classroom, the assessments the students complete, and the professional practice they'll need in industry. So let's now take a look at how we can bring each of the performance outcomes to life in our teaching. So we'll start with performance outcome 1, which applies across all 4 occupational specialisms. So digital security isn't just a standalone unit, it should run through everything students do. We're not just teaching them what GDPR stands for, we're embedding secure practices into every task. So you could use scenario-based activities where students must respond to a simulated security breach or assess the risks in a given setup. In the classroom, you could set up routines that mirror what happens in industry, things like checking user access, handling permissions and logging in with proper credentials. This creates habits and fluency in applying safe and compliant practices consistently. And now moving on to performance outcome 2. So this outcome looks different depending on the route, but the principle is the same. Learners must demonstrate core technical competence in their role. So whether they're configuring a network as an infrastructure technician, resolving a user ticket as a support technician, laying cables as part of the digital infrastructure, or remediating security risks as part of cybersecurity, learners must follow standard procedures, justify their actions, and complete tasks to professional standards. So a good strategy here is modelling full technical workflows, not just isolated skills. For example, show students how to go from planning a solution through configuration, testing, and documenting the outcome. Drills and SOP-based practice can also help develop precision, while checklists can help to build confidence and consistency. Then for managing performance outcome 3, this is all about research and judgment. Students need to be able to find the right information, assess its reliability and apply it appropriately. We can build these skills by designing tasks where students must solve a technical issue using a real-world source, such as vendor documentation from Microsoft or Cisco. Then ask the students to justify their choice. Why this solution? Is it the most reliable or efficient one? You can also explore the difference between official guidance and community forums, and this might encourage critical thinking and show students how professionals vet and apply information in the workplace. And here are a few strategies that apply across all of the outcomes and specialisms. So start early, introduce the performance outcomes right from the beginning of year 2 and embed them into your routine classroom tasks. Reinforce security in every practical session, not just the ones labelled cyber. Unify your activities, so things like ticket logs, troubleshooting reports and post-task reflections can really help support multiple performance outcomes at once. And encourage students to think aloud and explain their choices. This builds a reflective mindset and reinforces professionalism. And finally, gradually shift responsibility, so move from structured guidance towards learner independence. This will mirror what they'll face in assessment and in the workplace. Let's walk through the 3 assignments that make up the digital support occupational specialisms. So while each pathway focuses on a different technical context, Assignment 1 generally assesses the learner's ability to interpret a technical brief and identify client, user and system requirements, design or plan a technical solution based on those requirements, justify decisions made during the planning phase, for example, choice of components, configurations or security measures, demonstrate understanding of safe, compliant and professional planning processes, and to produce documentation, such as diagrams, specifications or risk considerations that communicate the plan effectively. So here's how you can prepare students to succeed regardless of their OS pathway. So technical brief analysis practice. It can be useful to use example briefs and ask learners to identify key objectives and constraints, list what information is missing, and break the task into logical stages. And in terms of planning and design walkthroughs, you could model how to select appropriate components or tools, how to create diagrams, specs and configuration plans, and justify choices using professional reasoning. You could also use real-world case studies, for example, installing for a small office or a school. Then make sure that you teach the structure and terminology of plans. So you could provide templates or frameworks for planning documents and practice writing up things like risk assessments, network diagrams, configuration tables or equipment lists. Then in terms of security and compliance awareness, you can embed digital security protocols into planning tasks. Things like device access policies, user permission structures, and patch or update scheduling. Then use peer and self-review of plans. So you could use checklists linked to the assessment criteria and ask learners to review a peer's plan and give constructive feedback. For example, does this solution meet the brief? Are risks addressed? Could you improve documentation clarity? And finally, use mock assignment 1 activities. So you can run scaled down mock tasks that mimic the structure and expectations of the assessment. Set time limits and simulate real assessment conditions. Follow up with reflective discussion and guided feedback. So assignment 1 is about helping students to shift from doing to planning and thinking like a technician. They'll need to show understanding of requirements, confidence in choosing appropriate solutions, and professionalism in documenting and justifying their approach. So your teaching here should focus on building the thinking, structure and planning fluency that mirrors the expectations of a real-world setup task. Assignment 2 moves from planning to hands-on technical execution and introduces support and problem solving. In all OS routes, learners will need to carry out technical tasks following procedures or specifications, responding to technical problems or user requests, test systems, validate performance or verify success, maintain compliance with safety and security procedures, document processes clearly, for example, test logs, instructions or maintenance records. And in preparation for this assignment, you could apply routine technical execution tasks, for example, using weekly drills or structured practice tasks based on things like installing or configuring hardware or software, responding to faults or user queries, running test plans or diagnostic tools, or investigating vulnerabilities or performance issues. Make sure to teach testing and troubleshooting as a process. So model structured troubleshooting, for example, identifying the issue, applying the fix, testing the outcome and recording the steps and rationale. And you could also use flowcharts or templates to reinforce logical thinking. Use simulated job request scenarios. For example, create realistic tickets or support scenarios, something like my computer won't connect to the network, or I've forgotten my password, or the firewall is blocking a necessary site, and let learners diagnose and respond using technical documentation and a help desk tone. Create and use test plans, so introduce testing documentation and protocols, for example, cable continuity tests for network cabling students, security audit checklists for cyber security, hardware or software configuration tests for digital infrastructure and support, and encourage learners to create their own checklists based on vendor resources. Encourage students to develop clear user instructions, so get them to practice writing concise, step-by-step guides. They need to be able to use non-technical language when appropriate and emphasize structure, tone and clarity. And you could reinforce this as part of Performance Outcome 3, which is communicating solutions effectively. And also use ongoing maintenance activities, so integrate scheduled tasks such as software updates or patching, physical hardware checks, or log analysis for vulnerabilities or errors, and ask students to document maintenance with reflections or review notes. And finally, encourage peer review and feedback, so use success criteria to evaluate things like technical accuracy, user accessibility of the documentation, completeness of testing or resolution processes. So overall, the teaching should help students move from step-by-step guidance to confident, independent execution, mirroring the pace and professionalism expected in the live technical roles. In all 4 OS pathways, Assignment 3 assesses students' ability to identify risks, faults or vulnerabilities in a system, evaluate the impact of these issues and propose suitable control measures or solutions, demonstrate understanding of system performance, security and recovery processes, use tools and techniques to analyse and report on the issue, and document technical findings clearly and professionally. And to support students to prepare for this assignment, you could introduce tools for system analysis, so teach students how to use appropriate diagnostic tools, for example, network monitoring software such as Wireshark or Ping, security scanners or audit logs, cable testers for network cabling, and run practice tasks where students interpret performance or fault data. Use risk assessment activities, so regularly incorporate small-scale risk identification exercises, such as what risks are associated with this system layout, or what would happen if this security control failed. And you could provide templates for completing structured risk assessments. Teach remediation and recommendation framing, so model how to move from identifying an issue to recommending realistic, cost-effective actions, justifying choices based on impact and business need, and prioritising based on severity. You could use sentence frames like, to mitigate this risk I recommend, or this control would reduce the impact because. Use scenario-based troubleshooting tasks, so simulate system failures or cabling faults, for example, and ask learners to diagnose the issue, document the findings, and propose and explain a solution, and emphasise a calm, logical, step-by-step approach to this. Secure deployment practice, so for digital support, practice remote imaging and deployment tools in class. Talk through the risks, checks and procedures before deployment, and rehearse writing deployment logs or post-deployment reports. Then for disaster recovery planning, for cybersecurity in particular, ask learners to imagine a data breach, network outage or a ransomware event, and get them to create a response checklist, a business continuity statement, or a plan for restoring services safely. And finally, professional documentation and clarity. So make sure you teach your students how to scaffold their technical report writing. This can be in terms of risk summaries, technical findings, and recovery recommendations. And reinforce audience awareness. So, for example, that reports must be clear for both technical and non-technical readers. Remember, Assignment 3 is where learners are expected to think like professionals. They need to analyse and diagnose issues, assess risk, recommend secure, effective and well-reasoned actions. So therefore your teaching should focus on giving students the structured tools for analysis and clear models for communication. so that if something goes wrong, they know how to respond confidently and systematically. This timeline offers a suggested structure to help students develop the technical skills, professional behaviours and assessment readiness required to succeed in their chosen occupational specialism. It introduces the 3 key performance outcomes progressively and builds confidence in preparation for formal assessment. So starting in the autumn term, firstly focus on the foundations of Performance Outcome 1, so applying procedures and controls to maintain digital security, and the early stages of Performance Outcome 2, which is the pathway-specific technical skills. And the suggested areas for focus are reinforce secure working practices and digital hygiene, things like logins, permission management and device handling. Introduce core technical workflows, for example, installing software, running updates and performing system checks. You could use SOPs and flowcharts to break down multi-step tasks and encourage learners to log their processes clearly and use standard terminology. And also build comfort with tools and environments that they'll use in assignments, for example, configuration interfaces, support platforms or patching tools. And then in the second half of the autumn term, which introduced task execution and troubleshooting. So deepen Performance Outcome 2 and begin Performance Outcome 3, which is to discover, evaluate and apply reliable sources of knowledge. So focus areas here could include practicing mid-level practical tasks, such as installing and configuring operating systems, troubleshooting hardware or software, cable termination, or responding to simulated user issues, depending on the student's pathway. Provide hands-on troubleshooting tasks supported by SOPs and ticket-style briefs. And introduce real-world documentation sources, for example, Microsoft Learn or Cisco Docs. You could run research-based activities where students must propose and justify a technical solution, and reinforce documentation accuracy, test logging and clarity in technical reporting. And then in the early spring term, think about assessment readiness in terms of mock assignments and consolidation. So focus on assessment practice linking to all 3 performance outcomes, and build familiarity with assignment structure and expectations. So some activities here could include running full mock assessments for assignments 1, 2 and 3, using time-bound scenario-based briefs that reflect the real assessment format. Use feedback sessions to highlight alignment to each performance outcome. So for example, assignment 1, installation and configuration planning, aligns to performance outcomes 1 and 2. Assignment 2, the end user support and documentation, can align to performance outcome 1 and 2. And assignment 3, system deployment, monitoring and analysis, would align to performance outcomes 1, 2 and 3. And you could scaffold reflective tasks here that ask learners to evaluate their accuracy, efficiency and compliance. And practice remediation planning based on test results or log data. This is especially relevant for cybersecurity and infrastructure students. And then in the second half of the spring term, it'll be the controlled assessment delivery window. So here, focus on the final preparations and delivery of the OS controlled assessments. Some supported strategies could be that you ensure learners are confident with the format, timings and expectations of each task. Use pre-assessment rehearsals to embed time management and precision under pressure. Reinforce secure practice, clarity of written communication and confident use of terminology. And offer support for organisation and stress management during the assessment period. Of course, this is just a suggested planning framework adjusted to suit your learners and delivery model. You may find it useful to plan backwards, so design your curriculum with the performance outcomes and assessment tasks in mind. Embed secure working practices and task structure from day one, and this will help students build fluency through repetition, feedback and real-world application, whether that's deploying a system image, logging a support case or proposing a cyber risk fix. So now let's look at some practical ways to bring these occupational specialism skills to life in your classrooms and workshops. So classroom walkthroughs. First, model the whole process yourself. Show students exactly how you interpret a technical brief, how you plan your approach, execute the task, whether that's installing a device, configuring a system, or running a security check, and then test and document your results. Talking through your decisions aloud helps demystify what good practice looks like in real time. You may find it useful to use checklist-based routines. So these can help to build fluency, whether it's running software updates, applying patches, prepping cables, or completing logs. Students can benefit from repeating these core procedures until they feel like second nature. And using simple laminated or digital checklists can give them something concrete to rely on. Introduce peer reviewer roles. So peer observation is a powerful tool. You can set up structured opportunities where students watch each other perform a task and then give feedback. You might use simplified criteria linked to the performance outcomes. For example, was the security process followed? Were all safety checks completed? Is the documentation clear and accurate? And this helps learners develop both reflective skills and professional judgment. Use structured write-ups, so embed regular reporting and reflection. Have students practice writing support tickets, test logs, installation records, or risk assessments, and encourage them to focus on clarity, consistent formatting, and professional language. These are the same skills they'll need in their assessments and in the workplace. And finally, error spotting and remediation tasks. So make sure students can recognize and fix problems. Provide examples of flawed configurations or incomplete records, and ask them to identify what went wrong, how they'd correct it, and why it matters. This not only strengthens analytical thinking, but reinforces safe, reliable practice. So overall, these strategies don't just prepare learners for controlled assessments, they do help them to build confidence, accuracy, and professionalism that they'll carry on through their careers. So now we're going to talk about assessment fluency. So this is the kind of fluency that goes beyond just knowing the task. It's about understanding what success looks like, how to show it, and how to communicate it clearly. In Year 2, learners do need this fluency across all parts of their occupational specialism, from planning through to execution and reflection. So how can we help them build that? So we could start by colour-coding tasks linked to the specific performance outcomes. For example, if students can see that they're practicing PO2 and then see that same skill area reappear in assessment brief, they begin to connect the dots. So it's all about making the hidden structure of the qualification more visible. Next, normalise assessment formats through weekly mini tasks. These could be short activities where students prepare devices, validate data, respond to user issues, or document troubleshooting steps. They're not just rehearsing the assessment, they're building familiarity with how to apply their skills in a realistic environment. Then there's scaffolding written and verbal activities, especially for responses to typical task prompts. So you could use sentence starters, such as, to maintain digital security, I would, or the technical steps I followed were, or a reliable source I used to inform my decision was. And encourage learners to speak their answers aloud first, and then reflect on how they can translate that fluency into written evidence. Use peer feedback regularly, not just at the end of a task. Provide simplified success criteria and get students to review each other's work using phrases like, this demonstrates PO1 because, or to improve this, you could explain how the security procedure protects user data. And finally, encourage students to reflect on any practical experiences, such as working with live systems or simulated service requests, using assessment-aligned prompts. Because assessment fluency isn't just about memorising the script, it's about building clarity, confidence, and professional competence, so students can think and work like digital support technicians. It's important to recognise that students often feel pressure in Year 2, especially around the occupational specialism projects and assessment deadlines. That's why creating a learning culture that values progress over perfection is key. So start by making a space for mistakes. Ask what went wrong, what could I try next? This normalises iteration and growth and becomes part of the normal learning process. Before major tasks, you could offer verbal walkthroughs to help reduce anxiety and allow students to rehearse their thinking. Talk through expectations and break down complex steps out loud. Scaffold planning and reflections, especially where written communication is required. You could use sentence starters, peer dialogue, or structured frameworks to help students process and structure their ideas more clearly and ease their cognitive load. And make sure to set up a calm, focused environment before technical assessments. Something as simple as a quiet, tidy workspace, a predictable routine, brief mindfulness exercises, clear checklists, or a quiet 5 minutes can make a big difference. And finally, remind students that working with data, like in any tech setting, often involves uncertainty and iteration. Progress and problem solving are more valuable than getting it right first time. When they feel frustrated or unsure, acknowledge these emotions and help them link that experience to real-world professionalism, resilience, and adaptability in the tech industry. Because ultimately, technical skill is only part of the picture, emotional confidence matters just as much. This slide just gives you some examples of the support and resources available. So from the NCFE qualification page, you can find things like the Chief Examiner reports and student exemplar assessment materials. And on our events page, you'll see where we have upcoming CPD sessions and things like drop-in clinics. And we also have our YouTube playlist, which contains a lot of on-demand videos covering many areas of the qualification. So the links are there on the screen for you to use as appropriate. So before we finish, I'd really appreciate it if you could take just a few minutes to complete this short feedback form. Your insights really are valuable because they help us improve the content, delivery and usefulness of these recorded on-demand resources. So simply scan the QR code on the screen to get started. And thank you in advance for taking the time to share your thoughts, and we hope to see you at our upcoming events. Thank you again, and I hope you found this video useful.